Okay, guys, welcome. Today we're going to talk about direct and inverse variation. So this is sort of a special relationship between two or even more than that variables. All right, so first, what do we mean by direct variation? Well, we say that two quantities vary directly if an increase in one of the variables causes a proportional increase in the other one, right? So, for example, let's go ahead and we'll look at the table, right? If you look at your x's, each time you're increasing by 1. And if you look at your y's, each time there, you're increasing by 3. Right? Now, of course, one thing that also happens is if you look at y over x in each case, so this is 3 over 1, this is 6 over 2, this is 9 over 3, and this is 12 over 4. If you reduce all those, every time you're going to get 3. And when that happens, that's an example of direct variation, right? So if we say, for example, that y varies directly as x, that means that you have that y is equal to k times x for some number k, right? And of course, in this case, that number k is 3, because that's what you get when you look at y over x each time, right? So of course, you can have things like y varies directly as the square of x or directly as the cube of x and so on and so forth. And we'll do a couple examples with that. One thing that I did not mention yet is that k is considered to be the constant of variation. Right? So if they ask for the constant of variation, that's what they mean. Okay, so let's go ahead and we'll take a look at an example. So we want to write the appropriate equation, solve for the constant k, and then we'll talk about how we can use k to relate the variables. So in part A, we're told that d varies directly as t. So if you have that v varies directly as t, that means that d equals kt, right? And then we're also told that d is equal to 15 when t is equal to 2, right? So the first thing that we need to do is we need to solve for k. So if we solve for k, we know that when d is 15, t is 2, so we can get fairly quickly, once we divide by 2, that k is equal to 15 over 2. So then the general equation looks like d equals 15 over 2 times t. Right? So we just replace k there. Okay, part B, we have that y varies directly as the cube of x. So that's y equals k times x to the third. Right? And we're told that y is 24 when x is negative 2. So if we plug this in to solve for k, we'll get that 24 is equal to k times negative 2 to the third. So we get 24 is equal to negative 8k. So k is negative 3. All right, so then what's the equation look like? It looks like y equals negative 3 x to the third. Okay, part C, we have that p varies directly as the square of v. So p equals k times v squared. And then p is equal to 64 when v is equal to 16. So again, first we'll solve for k. So we have that 64 is equal to k times v, which is 16 squared. So if we square 16, that should give us a 256. So 256k. And then if we divide both sides by 256, we get k is equal to 64 over 256. And I believe that this gives us k is equal to 1/4. Right, if we do 64 times 4, we got 240 plus 16. So yeah, so that will work. K is 1/4. So then, of course, what's the equation look like? It's p equals 1/4 times v squared. Okay, and then finally part D, we have that the circumference of a circle C varies directly as the radius, right? So we have that C is equal to K times R. All right, so we're told that C is equal to 25.13 when R is equal to 4. And we want to write C as a function of R, so we just need to find K and then write that equation. So if we plug in, we get 25.13 is equal to K times 4. All right, so then we get that K is whatever 25.13 divided by 4 is. And of course, if we solve this in a calculator, we're going to get that 25.13 divided by 4 should come out to be 6.2825. So of course, we're going to get that C is equal to 6.2825 times R, right? And this should look somewhat familiar because we know that if you wanted to get the circumference, you would just take 2 times the radius and multiply that by pi. So this is 2 pi r. And if you look at 6.28, that looks about what 2 pi is, right? So you get 6.2825 here. Okay. So the other part of this section that we can talk about is what's called inverse variation, right? And this is sort of the opposite, right? So we say that 2 quantities are said to vary inversely if an increase in one causes a proportional decrease in the other, all right? So you can see here that when you add 1 each time to your x values, you're getting sort of this decrease happening each time, right? And the idea is that if you look at the product x times y, you get the same thing, right? So if you look at x times y and x times y, x times y, x times y, each time you get 24, right? So that's how you can check if you have 2 quantities that are varying inversely with each other, right? So in this case, we can say that something like y is equal to 24 over x. And in general, if y varies inversely as x, that means that y is equal to k divided by x. So that's sort of the key here. Okay, so let's go ahead and take a look. So if we have that m varies inversely as d, that means that m equals k over d. And then we're told that m is 9 when d is equal to -3. So first, let's plug in and we'll find k. So we get that 9 is equal to k over -3, which once we multiply will give us k equals -27. So once we have that, we can say that our equation is m equals -27 over d. Okay. Part B, that was part A. Part B, we have that y varies inversely as the square of x. So this is y equals k over x squared. And we're told that y equals 10 when x is equal to 10. So if we plug in and we solve for k, we get 10 is equal to k over 10 squared, which is 100. So once we multiply, we get k is equal to 1,000, which gives us the relationship between x and y. We're going to get y is equal to 1,000 over x. Okay, and then part C, we get that v varies inversely as the cube of w. So v equals k over w to the third. V equals 2 when w equals -2. And we want the constant of variation. So we're going to get that 2 is equal to k over -8. So k is equal to -16. So then finally we get that v is equal to -16 over w to the third. All right, so those are some inverse variation problems. Okay, now the last thing that we will discuss in this video is the idea of joint variation. So now, of course, an equation of variation, you can have more than two variables. In all the examples we've looked at, we've just had two variables. Okay. Now, we just say that a quantity varies jointly if we have two or more quantities, if it varies directly as their product. So we'll do a couple examples of that. Right. So as an equation, in part A, we have that P varies jointly as R, S, and the square of T. So that just means that P equals K times the product of R, S, and the square of T. So R, S, and T squared. So we could write this as P equals K, R, S, T squared. Right. And of course, if we had some other information, we could solve for K, but in this case, that's as best we can do. Now, if we have that M varies jointly as P and Q, then we get M equals K times P and Q, but also inversely as D. So as soon as we see inversely, we need to send D to the bottom. So we get M equals K times PQ, all divided by D. Okay, so I believe this is the last slide. So now we can incorporate, well, what happens if we now know some of these values, all right? So now A, we have that X varies jointly as Y and Z, so Y equals K times Y times Z. And we're told that X is 30, Y is 2, and Z equals 3. So if we plug this in, we get 30 is equal to K times 2 times 3. So we just need to divide both sides by 6. And we'll get that K equals 5. So then our equation is X is equal to 5YZ. And then part B, we want to find the constant of variation of X varies jointly as Y and the cube of Z. Need a K here. And inversely as T. So we're going to send T down here. All right. And we have that X is negative 1/4. Y is negative 1. Z is negative 2. And T equals 4. So if we plug all this stuff in, we're going to get negative 1/4 is equal to K times negative 1 times negative 2 to the third over 4. So let's go ahead and we'll clear our fractions. This will be nice because they're both going to just cancel. If we multiply both sides by 4, we get negative 1. And then on the right side, we're going to get a negative 8 from the negative 2 cubed times negative 1 is a positive 8 times K. Right? So then it looks like we're going to get that K is equal to negative 1/8. Right? So then it looks like we're going to get that X is equal to K, which is negative 1/8. And then I have Y, Z to the third in the top and T in the bottom. So there's my equation. Okay, so that concludes this video on direct and inverse variation. I hope you enjoyed, and I will see you next time.